I'm going to do a quick little overview of different ways of factoring polynomials. So I'll be doing one example of each type, and we're going to start with greatest common factor only. So let's go here. Notice here that if I was to separate out all the factors of each term here, I can actually pull out a negative 10b. And then what I'm left over with in this term is just a b. And here I'm left over with a plus 2. And so if I was to redistribute this to there and there, notice that I indeed would have negative 10b squared minus 20b, right? I would have that. So this is our goal. This is our goal here. We want to have a factored version. So that is called greatest common factor, because you're just pulling out a greatest common factor out of these two. So you're looking for the same greatest common factor, common being, common to both of them. Just like back in the day when we were doing that in more simple math classes. So we can do one like this. Now here, when you have 4 terms, you're going to be looking at something called grouping. And when you're grouping, essentially you start like it's given to you, and you just insert parentheses like this around the first 2 terms and the second 2 terms. Now, it's a little bit trickier when the third term is negative like this. Let me actually start by doing this one, and then we'll work back to that one. So I'm going to put my parentheses around. Notice my third term is positive, which is very, very different. So my third term is positive, so that's important. So I've grouped these two and grouped these two. And then I'm just going to do a GCF, greatest common factor, for this group and for this group. So coming out of the first group, I have, what do I have? I have a 2 and an n squared. And that leaves me with a 5n and a negative 4. And then in the second group, I have a 7, right? A 7. So if I pull out a 7, then that's going to leave me with a 5n and a minus 4. Now notice here that what I have left over here and here is the same. So now I want you to think of this as like 2 different things right there. And notice that I have something times 5n minus 4 and something times 5n minus 4. So now I can pull the 5n minus 4 out, and I'm left with 2n squared plus 7. So when I took that out, the 2n squared and the 7 became my new leftovers, and this is what I've pulled out. Okay. So now the difference with doing this with a with a negative third term is that you have to actually kind of group in the negative sign with that, because the 49 is negative, and then you're adding an extra plus sign in there. So essentially what you're saying here is you're just making it like this. See how that doesn't actually change anything? I'm changing the subtraction into a plus and negative, and now I can do that, and it doesn't mess up anything else. If I had actually made this a negative of this whole thing, then it would have turned this negative 28 into a positive 28, which I don't want. So we'll do the same thing. Pulling out of here, I've got 5x squared. Left over gives me 7x, and left over gives me 4. And here, and I notice with the negatives, you've got to be kind of creative. If I pull out a negative, I'll be left with a positive here and a positive here, which is what I want. So if I pull out a negative 7, that's going to leave me with a 7x, and it's going to leave me with a positive 4. Okay, which is good. So I have the same leftovers here. I've got the 7x plus 4 and the 7x plus 4, and so then I can group the leftovers together, and that's what I'm pulling out. And you can write these in either order. It doesn't matter. Okay, so that's grouping. That's grouping. Grouping. Now we're going to do one where it's a trinomial with a equals 1. And when I say a, what I'm looking at here is I'm looking at ax squared plus bx plus c. I'm looking at this leading coefficient in front of the quadratic term right here being a 1. So indeed that's what we have, because that would be a 1 in front of the x squared, right? So the way I would go about doing this is you're looking for two numbers that multiply and give you negative 30 and add and give you negative 7. And so what comes to mind is negative 10 and positive 3, because notice if I take negative 10 and a positive 3 and multiply them, I get negative 30, and if I add them, I get negative 7. Okay? So essentially what you're going to do here is you're going to look for factors of negative 30. You're going to look for factors of negative 30 that add to give you negative 7. So negative 10 and 3 would do it. An example of something that would not work would be like negative 6 and 5. If I added those, I would get a negative 1. Or negative 15 and 2. If I added those, I'd get negative 13. So, neither of those work. This is the one that does work. So then I take those, and those become my tail ends here. So I split it up like that. And I'm going to have two binomials here. And I just take the negative 10 and I put it right here, and the positive 3 and I put it right there. Now the reason that I'm doing this is that if I FOIL this, right, and we've already learned about foiling, if I FOIL this, I'm going to get x squared minus 10x plus 3x minus 30. And if I combine the two middle terms, I'm going to get exactly what I wanted. So there is my answer, x minus 10 and x plus 3. Let's do one where there is a common factor to be pulled out, like right here. Notice my leading coefficient is not 1, but a 4 can be pulled out as a common factor here. So I can actually do this like this. Plus that. So notice I just have a 4 greatest common factor on this. And so now I can split that up. I'm looking for two numbers that add to positive 6 and, multiply to positive 6 and add to negative 7. I get negative 6 and negative 1, and there I go. Okay. I'm also going to do one that that does not work on. This is has an a is not equal 1, a is equal to 5, but also there's no common factors here. So what you do is you want to split up the two. You want to split up the b term right here, the linear term, into two things that would add to a factor of. Let me just stop really quickly. What I need to do is I need to check. You have to check a times c. A times c. If I multiply 5 and negative 8, I get negative 40. And I'm looking for things that multiply to negative 40 that add to 6. So a 10 and a negative 4 would do it, because if I multiply those, I get 6. If I add those, I get 6. So the way I do this is I split up my middle term like this. Okay? So that the plus 6x becomes that. And then I'm just going to group and factor. So here I can pull out a 2, not a 2, goodness gracious. I can pull out a 5x. 5x, and what's left over is an x plus 2. Here I can pull out a negative, here I can pull out a negative 4, and I'm left over with an x plus 2. Then I've got 5x minus 4 and x plus 2. Okay? Last thing I'm going to teach you how to do is special cases. So notice here that there's only a quadratic and a constant term. This is actually a difference of squares. So notice that this is a square and the square root of it is 5r and the square of that is 3. Or excuse me, the square root of that is 3. And so what you're going to do here is you're just going to jump straight to the factors, and one comes with a plus and one comes with a minus. And if we were to FOIL this again, we would get 25r squared. Notice that the middle two terms annihilate each other, and that's how we have what we started with. The other thing I want to show you is how to do a perfect square trinomial. A perfect square trinomial has perfect squares in the first and the second. So notice that the square root of 4n squared is 2n, the square root of this is 3, and then you want to check for this middle term, is it 2 times a times c root? Is it 2 times the roots of those? So if I take 2n times 3, I get 6n, and if I double that, and I get 12n. So I know I have a perfect square trinomial now. So I can go 2n and 3, 2n and 3, and then the symbol in the middle here is either going to be both negatives or both positives. You decide which one it is based on this. If this one is negative, you want these to be negative. If this one's positive, you want these to be positive. Because, notice what's going to happen here. If I FOIL this, I get 4n squared. I get minus 6n minus 6n plus 9. And if I combine those, and you see if these would have been positives, right, then these would be positives, but they aren't because I need it to go to negative 12. So this becomes negative 12n plus 9.